So we have learned about two types of the conic section, circle and parabola. Then we learned about two more, ellipse and hyperbola. Talking about the conic section, ellipse we will get if we will have a cone. If we have a cone and we not very nice cone. And we make section of the cone like this with a plane. And the shape that we will get with plane intersect cone will be ellipse. Circle, if we will do horizontal cross section, remember? Parabola we get if we will get a cross section parallel to the side of the cone. If we make the next section, if we have two cones positioned like this, and we make a section like that with a plane, we will get hyperbola. We will get two open lines. Ellipse is a closed line, hyperbola is open line. That we will get two lines like this. Now, we don't. It's interesting to talk a lot about both of them, about the definitions and properties, because there are a lot of actual things in real life when it happens. Ellipse, for example, as we talked about before, the orbits of the planets in the solar system, they are not circle, they are ellipse. Shape of the planet, shape of the Earth is not a sphere. It's actually ellipsoid. It's not the same. It's at the poles. It's a little bit sort of squashed a bit. And the same thing with the sun and so on. Hyperbola happens like in real life situation in many real situations as well. And ellipse, if we look into the ellipse, and this will be how we can get ellipse. If you take 2 points, which called focal points, foci, and we make the sum of the distances from any point on the ellipse, sum of the distance to each focal point will be the same for all points of ellipse.
So is the focus like a parabola?
So we have parabola that was the same distance, point, and a straight line. Here, same distance, sorry, not same distance, it was the same distance, now it's a sum of the distances. If you take d1 plus d2, for any point on the circle, it will be the same number. You know, so on the ellipse, it will be the same number.
d1 plus d2 will be the same.
Is a constant, yes, for ellipse. That's how we get ellipse. To draw perfect ellipse, you can, let's say, put 2 pins on the paper, take a piece of thread, make it as a closed circle, you just tie it up, and then you take a pencil and you let the thread go around it, and then you make a shape, and you will draw ellipse. Now, we don't have time to go over all things with ellipse. We'll go to what you actually need to know.
Yes.
It is the Cartesian equation of the ellipse. If we have ellipse not at the center of the Cartesian plane, if we have ellipse here, with the center HK. And also we have that this will be distance, it's called semi-axis A, and in the vertical direction it's B. So we have ellipse, we have a center, and we have semi-axis. These are from the center here, and from the center here, semi-axis. The Cartesian equation of the ellipse will be x minus h squared over a squared plus y minus k squared on a b squared equals 1. That is a Cartesian equation of the ellipse.
So it's the same as the circle, but there's a squared over b squared in the same axis.
Yes, for the circle, we have the semi-axis is the same a and b. In this case, this is showing that it is longer in one direction.
That makes sense.
And we have one term, it called eccentricity of the ellipse, which is equal eccentricity equals square root of 1 minus b squared over I over a squared.
What does it mean?
It's called eccentricity. It is give you pretty much now, and there is another way of defining ellipse. That is the same distance that ellipse is ratio, not the same, but the ratio between distance to the focus, one of the focus, and we draw another straight line, another directrix, and the ratio will be always this of the distances from any point on the ellipse to the focal point and to the directrix. This ratio always will be equal eccentricity of the ellipse. This number. Yes?
What is the focal point defined?
Focal point is, as said, is the 2 points. How we define ellipse? Ellipse is a locus of points. The sum. So we have 2 points, two focal point, two focal point.
How do you find where they are?
Are they given?
Yeah, you're given
At the moment we focusing on the center and working with the Cartesian equation of the ellipse in this form. And that's what going into the 3-4 will be on the this year exam. It will be on the 3-4 exam.
Yeah.
This one, it will not be on the exam in this form.
Did they ever ask you to graph an ellipse in the special exam? Or like a parabola in these forms?
Especially in this form on exams coming up every few years. There will be questions related to this equation of the ellipse. Let's consider an example. Page 20 of the booklet, and example 2. Let's consider example 2. Sketch the graph of, and we have 9x squared minus 72x plus y squared minus 4y plus 112 equals 0.
Complete the square knowledge.
So, before completing the square, no, we can. So let's do for x, we have take 9 as a common factor. So we group first x squared minus 8x plus y squared minus 4y plus 112 equals 0. Then we do 9, we have x minus 4 squared minus 4 squared. Completing the square for this, plus y minus 2 squared minus 2 squared plus 112 equals 0. Expand brackets.
Yes.
I mean expand only this bracket.
Yeah.
So we have 9 times x minus 4 squared minus
44.
we have 4 squared 16, 16 times 9 is 144, yes, minus 144 plus y minus 2 squared, and we have minus 2 squared, so we have plus 108 equals 0.
That's 4.
9 times x minus 4 squared plus y minus 2 squared equals, if you move, it's there we have that will be 36
Negative 36?
and
No,
positive.
36.
And now
Divide by 9.
we divide by 36, we want 1 on the right hand side.
Oh, it's like the linear expression when you have the x-intercepts form. Like the same thing.
Yes.
Okay.
We divide them by 36 and we get x minus 4 squared over 4 plus y minus 2 squared over 36 equals 1. I divided both sides by 36
Yeah.
to get 1 on the right hand side. So this is the equation of the ellipse. What are the coordinates of the center?
4, 2.
Coordinates of the center are 4, 2. Now, what are the semi-axes? A in the horizontal semi-axis is 2.
Oh, why 2?
This is an a squared. It's a square of the
Right,
semi-axis.
it's a square.
And b equals 6. We have pretty much almost everything to sketch the ellipse. So we have the center. So this ellipse, in which direction it will be longer? In the horizontal or vertical? It will be longer in the vertical direction. So we have center 4, 2. Now, because it's going down,
No,
by
it would be longer in the horizontal direction.
No.
no,
Because B is your vertical.
No, B is your horizontal. You just showed
no, A
Why
is
minus
horizontal. A
A?
is horizontal.
A.
A is horizontal. B is vertical. Semi-axis.
I just drew this. You wrote. You
No, I wrote it.
No, you're
A
wrong.
and B. You mixed A and B. Now, because we have semi-axis equals 6, vertical semi-axis, there will be x-intercepts. Will be there any y-intercepts?
No.
Because we have this is 4 and semi-axis is 2, so it will not go there in the semi-axis.
Oh.
But there will be x-intercepts. Let's find x-intercepts. Find x-intercepts. We take y equals 0. We get x minus 4 squared over 4 plus.
We're doing x-intercepts?
I find an x because
Yeah.
when we sketch any graph, we need to find the intercepts.
Okay.
Plus, we have this will be 2 squared 4 over 36. So 1/9 equals 1. We get x minus 4 squared will be equal. We get 8 or 9 times 432 or 9.
Negative. Yeah. Yeah. Wait. I
Third.
think negative. Oh, no,
We have
it's
this
fine.
is on 4.
Yeah.
Plus 1/9, we get minus with 8 on 9 times 432 on 9.
Yeah. Yeah.
And that will be not like exact number. We have x minus 4 equal plus minus root of 32. We can simplify 4 root 2 plus minus
4 root 2
divided by 3, 4 root 2 divided by 3, which is approximately root 2 1.4, so 5.6 divided by 3 will be about 1.9. No, yeah, around 1.9.
Okay.
So we have will be 4 plus 1.9 will be here. This will be 4 minus 1.9 up there. What will be the highest point of the ellipse?
I can tell you 6 number. No, 8. 4,8.
We have 4 plus vertically we have 6. Semi-axis is sorry 2. It's 2 plus 6 is 8. so we have 4, 8. The most left point we minus 2, we have 2, 2. The most right point is 6, 2. The very bottom point is minus 2, 4 minus 2. And this will be our ellipse. Not the best drawing, but that will be ellipse with those we found x-intercept. Makes sense how we get the graph of this ellipse.
Yeah.
Questions usually with ellipse on the exam get done pretty well. If you look on the question, the book it's over 73, 83%, 74.
How do you use 3?
Huh?
How do you use 3? Example
You
3.
complete the square.
Oh, true. You just don't know.
Example 3. You just complete the square, yes. So let's have a look into the hyperbola. And again, we will be, due to the lack of time, we go straight, even if there is quite a lot of interesting thing about the hyperbola, we're going straight to the equation, Cartesian equation of the hyperbola. Now, hyperbolas and ellipses are on your coming next week exam. No, not next week, week after.
Interesting. It will be a equal and then away.
So, hyperbola, we can have two cases. We can have hyperbola, because it looks like this, or we can have hyperbola looks like this. So that's case number 1. I will call it, it's not exactly, we'll say horizontal hyperbola. Case number 2, vertical hyperbola.
But the hyperbolas that we learned in methods is so different. Why?
There's another one.
Because we learn, like...
You learn rectangle. It's called rectangular hyperbola.
Right.
It's called rectangular hyperbola. This is a general thing with a hyperbola. And what the equation will, let's start from this one. This will be x minus h squared over a squared minus y minus k squared on 2 equals, on b squared. On b squared
Same as ellipses
equals
minus.
1 minus.
Yes,
So
minus.
this will behave that we will have the difference in the distances will be the same. Ellipse we have sum of the distances was the same. In hyperbola we have a difference between distances. This is for horizontal. For vertical, for case number 2, that we will have y minus k squared
Minus.
over b squared minus x minus h squared over a squared equals 1. So whatever we have with the plus, if we have x squared with the plus, we have horizontal hyperbola. If we have y squared with the plus, we have this case. Now, what are the points? What are h and k represent, and what a and b will represent in this case? So if we have the hyperbola, looks like this. Hyperbola will have asymptotes. Hyperbola will have asymptotes. And I'm drawing hyperbola with the center at 0, 0, which is HK is the center of hyperbola, and this is the point of the intersection of the asymptotes. So we have two asymptotes.
What are these asymptotes?
And we will have hyperbola looks like this.
So it's like an oblique asymptote.
And Yes, oblique asymptotes, yes. Equation of asymptotes is y equal plus or minus b on a times x minus h plus k.
Jesus.
These are the equations of the asymptotes.
For both of them?
One with the plus, one with the minus.
Plus is for the original one, right? Vertical one.
There is no vertical. We have
No,
two.
I
We
mean,
have
plus
two
is for
oblique.
the-
We
Oh,
have
no,
two
Joseph,
oblique-
they'll be the same asymptotes.
I mean, the plus is for
They'll be the same asymptotes.
No,
the plus is
no. We have plus. We have for this asymptote. Minus we have for this asymptote.
Yeah.
But this point is HK. HK, the center, is where they meet. Where they meet. Point of intersection of the asymptote.
And we need to remember all of this, like for like exam 1 for the stage, if it's on it, not for the 3 4s.
It is. Now,
Where's the focus?
this is A.
There's no focus, it's the
This, in this case, there is no representation of B on the graph. A will be this distance from the center to the vertex, and this will be A. In case of the vertical position hyperbola, the distance will be B from the center to the vertices. Let's consider an example. Let's consider an example.
What do you mean could be? Like you talking about if it's like
We have this number, you see B.
yeah.
There is no direct representation on this graph.
But for
of
the other hyperbola like this, then it's B, right?
Then it will be B, yes. But will be no direct representation of A.
So what is the
Hmm?
What is
A is the distance from the center to the vertex. From the center to the vertex, or turning point. And it's not turning point in terms that derivative equals 0, because obviously in this case, what will be derivative at this point?
Nothing. Undefined.
Undefined,
Vertical tangent.
not nothing, undefined with the vertical line.
Mm-hmm.
Yeah, so it's not derivative, so turning point, not in terms of the derivative. The hyperbola turns around.
But the turning point is the x-intercept.
Hmm?
The turning point.
In this case, because I take k equal,
It's the x-intercept.
but it doesn't have to be going like this vertex on the x-axis.
Yeah.
So let's consider example 2, page 26. Let's consider example 2, page 26. Sketch the graph 9x squared minus 54x minus 16y squared minus 127 equals 0. Again, we take common factor 9x squared minus 6x minus 16y squared minus 127. We complete the square. 9x minus 3 squared minus 3 squared minus 16y squared minus 127 equals 0. Expand this bracket. 9 times x minus 3 squared minus 81 minus 16y squared minus 127 equals 0. So we have 9x minus 3 squared minus 16y squared will be equal to 108.
108.
200.
So 108, yeah.
208 equal to 108. Now what the next step?
Divide by 208.
Divide by 208 and
It's not factorizable, is it?
no, something to write down everything correctly. 9 minus
208 and 9.
Oh, my bad.
Yeah.
Yeah. Yeah, so it's stop. I've write the question
Wrong.
wrong, and I actually type it in the booklet wrong because I'm looking at my solution. It is, that's why it should be in all those questions. It should be then this number should be product of these two.
Yeah.
So there is missing here minus 64.
Why?
Minus 64 y. I'm saying missing, I've just
Yeah.
realized that I'm looking at the number doesn't make sense.
Yeah.
So minus 64
4.
y, minus 64 y. That will of course change
So we're starting
what
with
happens here. So it will be minus 16, and we have y squared minus 4, minus 127 equals 0. So we have 16. And completing the square, 16, y minus 2 squared minus 2 squared minus 127 equals 0. So we have 9 times x minus 3 squared minus 81 minus 16 times y minus 2 squared. We have minus 4 times 16 plus 64 minus 127 equals 0. We get 9 times x minus 3 squared minus 16 y minus 2 squared, and that will be equals 144.
Yeah.
I think 144. Now we divide both sides by 144, and we get a final equation, Cartesian equation of the hyperbola, x minus 3 squared over 16 minus y minus 2 squared over 9 equals 1. What are the equations of the asymptotes?
Plus minus b on a.
Y equals plus minus.
B on a.
We have 3 quarters. A is 16, a squared is 16, b squared is 9, plus minus 3 quarters, x minus 3 plus 2. So we have expanding brackets, we get y equal 3 quarters x minus 9 on 4 plus 2, which gives us y equal 3 quarters x, and we have minus 1 quarter. And second equation of the second asymptote, y equal negative 3 quarters x plus 9 on 4 plus 2, which will be y equal negative 3 quarters x plus 17 on 4.
Yes, 17.
So now we can sketch the hyperbola. Now we
I'm
can,
confused.
yes.
The plus minus.
We do, that is one equation we take plus,
Yeah.
plus relate only to this. Plus 2 is always plus 2.
Yeah.
Then you take minus 3 quarters times x
Right.
minus 3.
Right.
Make sense?
Yeah.
So we have, now we can sketch, we have center, which is 3, 2. Center is 3, 2. And we have 2 asymptotes. One asymptote is, so we have 17 on 4, which is about this is 0.32. So this will be here. This is the one asymptote. This is 17 on 4.
Do you have to name your asymptotes correctly, like x-axis and like x-intercepts and all that? Does it matter?
Do you need to label x-intercepts of the asymptotes? Because you have point and must go through the center, which is 3,2.
Yeah.
So y-intercept will be enough.
Okay.
You have 2 points on one straight line, don't need 2 points on this one straight line.
Perfect.
And so another one is negative a quarter. So this is the second asymptote, negative a quarter. Now, what will be the coordinates of the vertices of the hyperbola? We have A equals, A equals 4, A equals 4, center is 3. So what will be the?
Negative 1.
1 will be negative 1 because we're going 4 this way.
Yeah.
So this point is negative 1, 2, and we have 7, 2.
Yes, 7. Yeah.
7, 2.
7's on the. Okay, it's fine.
And now we have everything to sketch the graph. We can find also the x-intercepts.
Does B actually represent anything in this case?
No, B is used only for equation of the asymptotes. So that is pretty much condensed explanation about the ellipses and hyperbolas, pretty much what you need to know, at least for the exams. And pretty much that's all is for the unit 3-4 exam. As well, you don't need for 3-4, it's not tested the finding those focal points and so on. It's only in unit 1-2, it's not in 3-4, but those things are in 3-4 and will be on your coming exam. Okay, like, subscribe and donate to help fight Russia and Hamas, support Ukraine and Israel.